What counts as a measurement in quantum physics? Imagine trying to catch a fleeting shadow in a dark room. In quantum physics, a measurement is like that act of catching, an interaction that reveals something about a tiny particle state. But it's more than just looking. It actually changes what you see. When scientists talk about a measurement in quantum physics, they mean any process that interacts with a quantum system to find out about one of its properties, like where an electron is or how fast it's spinning. Unlike in everyday life, where measuring something doesn't change it, in quantum physics, the act of measuring influences the system itself. Before you measure, a quantum particle exists in a superposition, meaning it can be in many states at once. Think of it like a coin spinning in the air. Until it lands, it's both heads and tails at the same time. The property you want to measure is called an observable, like position or momentum, and each observable has a set of possible results called eigenvalues. When you measure, the superposition collapses into one of these eigenstates, giving you a specific outcome. This collapse is like the spinning coin finally landing on heads or tails. The result you get from a quantum measurement isn't guaranteed. It's probabilistic. You can calculate the chances of each outcome using the wave function, but you can't predict exactly which one will happen before you measure. This randomness is a core part of quantum weirdness. When you measure one property, it can disturb the system so that measuring another property afterward might give different results. This is because some properties don't commute, meaning the order in which you measure them matters. For example, measuring an electron's position first can change its momentum, making the second measurement different from what you'd expect if you measured momentum first. There are different types of quantum measurements. The standard kind is called projective or von Neumann measurement, where the system fully collapses into one state. Then there are weak measurements, which gather partial information without fully collapsing the system, and quantum non-demolition measurements, which let you measure a property repeatedly without destroying the state. What makes quantum measurement so strange is that it doesn't just reveal reality, it helps create it. Until you measure, the particle exists in a cloud of possibilities. When you do measure, that cloud collapses into a single point, and the outcome depends on probabilities. This is why experiments like the double slit show particles acting like waves until observed, then suddenly behaving like particles. Understanding what counts as a measurement in quantum physics helps explain many cosmic mysteries and the strange behavior of particles at the tiniest scales. It's a process that actively shapes what we observe, making quantum physics one of the most fascinating and quirky fields of science.